All right, data and statistics people, we are headed towards our last lesson of this unit. And to be honest, this is one of the weirder ones. It's grown to be one of my favorites over the year, but it is a little bit weird. As you know, we have done stem and leaf plots, histograms. We talked about the shape that distributions can form in some of those visuals. We also talked about choosing the most appropriate measure, and today we're going to be going to box and whisker plots. This is our last lesson. This is also going to end up being a 2-day lesson. So if you don't feel super great about it today, don't worry. You're going to have another day to practice and hone this skill. Just as a fair warning as you start today, this lesson is a little bit longer and there's really no way around it. Just there's a lot to explain and a lot of steps, but set aside some time, be ready to focus, and you can tackle this. So the first thing is, what the heck is a box and whisker plot? A box and whisker plot, its main purpose is to show the spread of a data set. So I worded that as a visual tool that shows variability. There's that word we've used throughout this unit, variability. Variability just means like how spread out is the data. And without further ado, here is a box and whisker plot. Now, this is called a box and whisker plot, which sounds like a goofy name, but it's given that name because of the features of it, the visual features. So you'll notice the middle of this thing is a big rectangular box. That's the box part. And then these two line segments that are sticking out of either side, those are the whiskers. So that's why this thing is called a box and whisker plot, because it's literally a box with what looks like two whiskers coming out of either side. And all right, so here is what a box and whisker plot does. Let's say you've got a data set and it's got, I don't know, 100 values in it, 1,000 values in it, 10 values in it. No matter what, it takes that data set and summarizes it in 5 numbers. And you'll see on my box and whisker plot, I've put a green dot, a red dot, a blue dot, a red dot, and a green dot. Those dots each represent the 5 components of a box and whisker plot. So before we go and make one, let's talk about what goes into a box and whisker plot. So the 5 numbers that make up a box and whisker plot. Number 1, the furthest to the left green dot is the least value of the data set. Some people call this the lower extreme, but the smallest number in the data set, the lower extreme, that's going to be your first important data point. All right, the second data point, which I made red right here, that is something you've already found before. That's called Q1, or some people call it the lower quartile. Some of you noticed that when you did the IXL, for interquartile range, it asked occasionally what is the lower quartile. That's just another word for Q1. As a quick recap, that's when you've got a set of numbers, 1, 3, 5, 6, 7, 8. Let's put one more in there, 9. And you find the middle number, and then you find the middle of the lower half. That's called Q1, or the lower quartile. Oof, that's a bad Q. And then the middle of the upper half is called Q3, or to other people, they call it the upper quartile. But this dot right here, this is Q1. All right, and then moving on to our next point, which I've made blue, that is the actual median of the data set. So if you had a set of numbers, lined them all up and counted down to the middle and found the actual middle, like in this example, that's 6. That's what this is right here, the median. Then we've got our fourth data point, which is another red dot. This is going to be Q3, the upper quartile, something you already know, or at least you know how to find. And then lastly is the point up here, which I'm sure some of you could probably figure out based on this list and the colors. It's the greatest value of the data set. Some people call it the upper extreme. Because it's the most extreme point on the upper side of the data. But the biggest number, so if you lined your numbers up from least to greatest, it would be the greatest number. So what we've talked about right now is this visual thing right here. This is a box and whisker plot. And there are 5 numbers that you need to create a box and whisker plot. You need to figure out what's the lowest number, what is Q1, what is the median, what is Q3, and lastly, what is the greatest number. And when you have those things, you can create a box and whisker plot, which I'm going to do with you right now. So I know to those of you who don't like sports, I'm sorry, but we're going to be doing another sports example just because it's what I've used previously, and it's also pretty easy to follow with this data set. I will try to pull some non-sports examples as well for tomorrow, but for today we're going to roll with this. This chart right here shows through 7 games what were the points scored per game. So the first is a 10. The person scored 10 points in the game. We'll call it a basketball game. In the second game, they scored 17 points. In the third game, a little bit of a womp womp, they scored 5 points. Then they had a monster game, scored 32, 16, 18, and 20. So we're going to take this data and we're going to create our own box and whisker plot. So step 1, I'm a steps person, so I'm going to break this down into steps. There's kind of a few, so you got to follow along with me. But step 1 is put the data in order from least to greatest, which I will do for you right now. Bippity boppity boo. All right, so there's all 7 numbers, and they are put in order from least to greatest. That's step 1. Moving on to step 2. Think about the 5 numbers I said we needed before, right? We need the lowest, the highest, the median, Q1, and Q3. So putting them in order from greatest to least accomplishes a lot of that. But step 2, what's your highest and your lowest? Well, my lowest is 5 and my highest is 32. So we already have 2 of the 5 major pieces of a box and whisker plot. Cool. Steps are not so hard just yet. Next, step 3, find the median or the middle number. So if I counted in from either side, I would find that 17 is the one and only middle number. So 17 is my middle number. Remember, if there's 2 numbers in the middle, you have to find the average of them. So you add them up and divide by 2, and then whatever that is would be your middle number. In this case, there is one actual middle number, which is 17, so that's nice. All right, moving on to step 4. Step 4, what's the upper quartile? Q3. And the lower quartile, Q1. Well, since I found the median, I now have a lower half of data and an upper half of data. And the middle of the lower half is 10. There's 3 numbers, so the middle number. And then the 3 numbers that make up the upper half of data, the middle of that is 20. So I already have Q3, which is 20, and I have Q1, which is 10. Awesome. And so kind of take a break at this point. You've found your 5 key numbers. Some people call it the 5-number summary. But let's make a quick list, just so we have everything. Our lowest number in the set was 5, and our highest number was 32. The exact middle of this data set, the median, was 17, and the lower quartile was 10, and the upper quartile was 20. All right, we've pretty much done the hard work. If you feel comfortable doing that, you can make a box and whisker plot. You can do it. So here we go. My next step is going to be to take these 5 ingredients, these 5 key numbers, and put them on a number line. So we need to make a number line that somewhat matches this data set. And by matches this data set, I have to have something that goes from at least 5 to at least 32, and I need to count by something that's going to capture as many of these numbers as possible. I am going to count by 5s. I'm going to make a number line, get my number line, and I'm going to skip ahead so that you have a beautiful number line that you don't have to watch me make. And go! All right, so I've got a nice number line that matches the data set, And now what we're going to do is we are going to, step 6, plot these 5 numbers on the number line. So just so you can have them on the screen, let's see. My lowest number is 5, and since I can, I'm going to color code this. I'm going to plot my nice 5 here, and my upper extreme, I'm going to, so 30, 35, 32, somewhere in between there. Just get as close as you can. Then my Q1, I'll use a different color. Q1 is 10. Put that here. And Q3 is 20. So I'll put that right here. And I'll use a different color for the median, the middle number, which is 17. So it's a little bit past the 15. We'll put it right here. All right, we've plotted our points. We're so close to making our first box and whisker plot. The last step is to make a box and whiskers. And the way that you do that is you draw a box around the lower quartile and the upper quartile. So the box for your box and whisker plot goes right here. And you're also going to put a line going through the median. And the purpose of that is to really draw attention to where the middle of the data set is. Okay, and then the last thing you're going to do is you're going to draw lines that connect the lower quartile to the minimum, so lower quartile to the minimum, and the upper quartile to the maximum. Upper quartile to the maximum. And that is what a box and whisker plot looks like. As always, you should make sure that you've got a title in there. I'm going to title this Points Scored Per Game. Okay, and that is a box and whisker plot. Now, what is this showing right here? Well, this takes those 7 games and condenses it down to this 5-number summary, and anyone can glance at this and say, all right, this person had a low of 5 and a high of 32, but more importantly is they're going to be drawn to the box. The box right here represents where 50% of your data lies. So half of my data is in this box. Yes, they had a bad game. Yes, they had a really good game. But for the most part, this person scores their points right in this box, somewhere in here. And the further away that one of these whiskers is, the more of an outlier it is. So this 32 is really not typical. And this 5 is kind of removed. It's not typical, but 32 is even way more atypical. And why this is useful is instead of you looking at, like, remember when we first started the data and statistics unit, I showed you the slide that looks like this, has all these numbers. Instead of you being a data analyst having to look at all this and try to make sense of it, you can look at a box and whisker plot. You could even take 2 different basketball players, for example, and stack those box and whisker plots on top of one another. So the one that we made is this one on the bottom. And then here's another player, and you could quickly see, oh, all right, this player, this might be someone we want to scout. Their points per game is a little more consistently higher. The lowest of their low wasn't as bad as this person's. So this might be a player that we want to consider over this person. And you can stack a bunch of box and whisker plots. This data set told how many passes were completed by teams throughout an entire season. Well, let's take Liverpool, for example. They have 38 games in the Premier League season, and we want to condense what happened with Liverpool into 5 numbers. And you do that, and then look, here's their lowest amount of passes per game, their highest amount of passes per game, and for the most part, they're somewhere in here. That's typically where they score most of their data. 50% of the data is in here. Then you got a team like Man City. They have a even higher average of passes per game. You've got a team like Burnley. Theirs is a little bit lower. They're not as good. And then maybe if you're a data analyst, you could quickly see the trends. The teams that are on the higher side of the table that are better soccer teams, they tend to complete more passes per game than these teams that might not be as great. Um, anyways, I thought that'd be cool to show you. Um, the things that you should know, but when you look at a box and whisker plot, is number one, where is the data located? What I mean is, I said something before. I said that in a box and whisker plot, half of the data is located in the box, and there's a reason for that. One of the features of a box and whisker plot is that in each section, and by section I mean from dot to dot. So this is section 1, this is section 2, this is section 3, and this is section 4. Each section contains 25% or 1/4 of the data. So 1/4 is in each of these little spots, and that's why it is a fact that the box contains 50% of the data. Half of it is here. 1/4 of it's here, and 1/4 of the data is here. What I mean is, like, if you took every data point in the set and plotted them on this number line, 1/4 of the points would be in this spot, half of the points would be from here to here, and the other fourth would range from here to here. So when you look at a box and whisker plot, one thing you should instantly know is, where is the data? Well, I know that 1/4 of it's here, 1/4 is here, 1/4 is here, and 1/4 is here. That is something that you should know. You should, if you're a note taker, write that down. That's important. Commit that to memory. And that's your first thing you should know. The second thing that you should know is you should know something about the shape of the data distribution. So remember we talked about skewed left, skewed right, and symmetric. Well, box and whisker plots have those same descriptions as well. From these three, you can probably tell this in the middle is symmetric. Why? Because if I looked right in the middle, it's the same on the left as it is on the right. That is a symmetric data set. This over here would be a skewed left. Why? Remember, the tail tells you where it's skewed to. It trails off down here. There's a bigger gap down here. Most of the data is on the right, so that means that this is skewed left. And similarly over here, most of the data is on the left of this box and whisker plot. The tail is over here. So this, since the tail is on the right, this is skewed right. Here's the important information for that in case you want to write it down, but essentially it's the same as what we talked about with the other data displays. Wherever the tail is, wherever it trails off, that's the side it's skewed to. Just look, where is most of the data? Most of the data is on the right, so the tail is here, so it's skewed left. Most of the data is on the left, so it's skewed right. Since we've gone over what all of those things mean previously, I'm not going to go super into it, but there it is. You should be able to tell me, where is the data, 1/4, 1/4, 1/4, 1/4, and you should also be able to look at this and say, oh, this is a symmetric box and whisker plot. Oh, this is a skewed left. Oh, this is skewed right. At this point, I'm going to end today's lesson. There were some examples in the notes. I would highly suggest that you go over them, particularly as you're going through today's practice problems. I've gone over everything that you need to be able to answer those questions successfully. However, the examples do a little bit more of like real life application of some of the things that I've gone over. So if you get a little stuck, glance up at some of those example problems if you didn't look at them on your own. I'd go over them, but it would make this video go for quite a long time, and it's already pretty long. So this is it for today. If you have questions, as always, reach out or consult your notes. You can go back and rewatch parts of this video as needed. Anyways, happy mathing!